All right, 6.5, exploring graphs of the reciprocal trigonometric functions. All right, let's look at the first one. We have our sine graph starting off with the following graph. Here we go. And we want to draw cosecant. Cosecant is the reciprocal of sine. So, if we take the sine graph and we draw that, we can draw the reciprocal graph, knowing from before how to draw reciprocal. That is, that at every zero, we would draw a... Okay, so looking at this sine graph, what are the things we're going to find? Well, cosecant will have an asymptote at every zero of the sine graph. So that's where all your asymptotes are. And remember, at 1 and -1, something special happens there. Those are going to be your invariant points. So there's an invariant point at 1, and there will be an invariant point at -1. So, the next thing we remember is if the graph is positive, it stays positive. If the graph is negative, it stays negative. Also, if the graph is increasing in the original function, it will be decreasing on the new function, reciprocal function. So over here, the graph is decreasing, therefore the graph must be increasing on the reciprocal function. All right, so let's go over here. You see that the graph is decreasing on this part, so it will be increasing when I draw it the reciprocal. Over here, the original graph is increasing here, so therefore the reciprocal function will be decreasing. And here, folks, is your reciprocal of sine graph, also known as the cosecant graph. All right, let's look at the next one. Oh, wait, before we do this, let's look at the domain. The domain of this function will have restrictions at all of these asymptotes. So these restrictions is theta belongs to real, such that theta cannot equal the following values. Well, let's see where their values are. So we have it at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, and so on. So what we're seeing here is that every pi, it's growing. So n pi is going to theta cannot equal n pi, where n belongs to the world of integers. The range is going to be, so let's focus on that n right there, and we're going to look at the range. Range is going to be y belongs to real such that y is less than or equal to -1, or y is greater than or equal to +1. And this is the domain and range of the cosecant graph. Now, let's look at the secant graph. One other thing to note, folks, let's look here. There is a horizontal asymptote at y equals 0, because at y equals 0, this graph actually doesn't get there. It's 1 over sine theta, which is the so there implies that there is a horizontal asymptote. This graph does not touch this value at all, and it will move accordingly if we move up or down. And left or right, it would stay where it is, but definitely up or down, this horizontal asymptote will move along with it. All right, next part. We have the cosine graph. We are going to draw the secant graph. So let's first draw the cosine. Here are values for the cosine. And then now we're going to do our secant graph. So there's an asymptote at pi over 2, an asymptote at 3 pi over 2, and you will have an invariant point at, a horizontal asymptote at 0, invariant point at 1, invariant point at -1, another one at 1 again, and now we're going to draw the graph. The the function from here to here is decreasing. Therefore, the reciprocal function is increasing. From here to here, the function is decreasing, therefore must be increasing. And over here it's increasing, so therefore our function will be decreasing. And finally, in the last section, the function will be decreasing. So here is our secant graph, that is the one in black. And our secant graph will have specific domain. All right, now let's look at the domain for this. We've seen this before, so this should not be new. But let's talk about the domain. The asymptotes happen at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. If you remember from before, it is odd number of pi over 2's. Odd number of pi over 2's implies that it's going to be an even plus 1, so 2n plus 1, times pi over 2, where n is an integer. The range is going to be y belongs to real, such that y is less than or equal to -1, or y is greater than or equal to 1. Let's look at that again. Y is greater than or equal to 1. So this is our domain and range for this function, for the secant function. All right, one last one. Let's look at the tan function. Let's draw our tan function the way it is. Here is our tan. There's an asymptote at negative pi over 2 and another one at pi over 2. Our reciprocal function will have, so that's a cotangent x, will have an asymptote coming through the y-axis. Now, it will have a invariant point at -1 and at 1, and something strange will happen at those original asymptotes. Well, think about it. An asymptote implies there's a 0 in the denominator. When you flip that 0 in the denominator, means that you'll get a 0 in the numerator. That means that those asymptotes that were originally asymptotes will now, funny enough, turn into, strangely enough, folks, it will turn into zeros. That's right. So the function will actually have a 0 at the asymptotes that were originally there. And we will be graphing the function. So note here, the graph is increasing over here. So therefore you will find in that section that it will be decreasing. In this section over here, the function is increasing, as you can see with that line. It is increasing here. Therefore, the function will be decreasing on that side. There we go. And interesting enough. So, let's look at the domain and range. Domain for cotangent is going to be theta belongs to real, such that theta does not equal n pi, where n belongs to the world of integers. R, the range, will be y belongs to real. And that will be our domain and range. It'll be y belongs to real because this particular graph is actually going to if we were to continue it, it would continue on the other side, looking again like a cubic function. But flipped and replaced. So it's kind of weird. But the idea is it's the actual cotangent function. So remember, at the asymptotes, we got zeros. And at the zeros, we got asymptotes. And then remember the rules about increasing and decreasing at certain parts. So number 5 on page 344, okay, we had some questions about that. So this is one of the solutions that we figured it out, okay? And this is a solution that we did in class. Now, you'll have to go through it with someone involving this. I'm not going to explain it, but I'm just showing you all the different possibilities. You need to work on the homework. Hopefully you've done some of the homework to be able to answer these questions. The goal is, in this unit, is really just to be able to transform these particular graphs. You won't do heavy transformations, but the idea is you should be able to move these, especially translate them up or down. maybe a couple of stretches, let's say referring to this secant or the cosecant, and some vertical translations. I highly doubt you're going to have much of a horizontal translation, but you could. So the idea is you should be able to transform any of these particular graphs. All right, folks, that's the end of the video. Take care. Have a good night.